Hello again. All right, so today what we're going to do is we are going to continue working with our identities, which are currently showing on the screen for you, and we are going to cover one specific type of algebraic simplifying using common denominators. So these problems should be near the end of your packet they should be near the end of the section on using identities to simplify. It should hopefully be somewhere in the vicinity of page 8 in your notes packet. Okay, so what I'm going to do right now is I'm going to go over the algebraic skill. That's what's on the left, the algebra. And then on the right-hand side, we're going to apply that exact same skill with the trig. Okay, so first thing that we need to understand is that here we have two different fractions, and so what we will need to get is a common denominator. Okay, denominator. Nom. Okay, and in order to do that, we have to recognize that these two denominators are different, okay? Even though they look really similar, because they have like a 1 and an x, they are not the same. As soon as you have a different sign, as soon as you have addition or subtraction between terms, that makes them unique. And they are a group. They are together. So here's the deal. The left-hand fraction has 1 plus x in the denominator. So we need the right-hand fraction to have that factor also. So we're going to multiply by 1. But 1 is going to look like 1 plus x over 1 plus x. So that is our 1 right there. So all of this, when we multiply, gives us 1 plus x over 1 minus x times 1 plus x. Okay? It gives us those two factors. And then on the right-hand side, we had a 1 minus x. So we are going to multiply 1 minus x top and bottom because that's 1. That fraction in red is 1. We're going to multiply the left-hand side by that. So we're going to get 1 minus x over 1 plus x times 1 minus x. Now this is normally the place where people make a fatal mistake and they work backwards. Okay, the reason why we just did that was so our denominators, so this part I'm highlighting, that was not my best highlight. This part is identical. And now that's true. Both of them have a 1 plus x and a 1 minus x in the denominator. I know they're not in the same order, but that order really doesn't matter when we're multiplying. The purpose of that was so now we can actually add these two fractions together because they have a common denominator. So that common denominator is 1 minus x times 1 plus x. Write it however you want. And then when I do that, I am going to add 1 minus x and 1 plus x. So 1 plus 1 is 2, negative x plus x. So what happens when I look at this again? Negative x and positive x, those are going to cancel out. So I'm going to be left with 2 over 1 minus x times 1 plus x. Now, you can leave it like this, or we could distribute, and we would get 2 over 1 minus x squared, because we get 1 plus x minus x squared. So that's how we get 1 minus x squared. All right. The key thing is that we need to get a common denominator by multiplying each side by the other denominator and then simplify. So we're going to do that exact same thing over here. So I have 1 plus sign in the denominator. So I'm going to multiply my fraction on the right by 1 plus sign over 1 plus sign of x. And so that's going to get me 1 plus sine of x over 1 minus sine, 1 plus sine, 1 plus. That's an s, by the way. Okay. And then on the left-hand side, I'm going to multiply by 1 minus the sine of x because that's the other denominator, 1 minus sine of x. All right. So I have 1 minus sine of x over those two things, 1 minus sine and 1 plus sine. All right, I have a common denominator. So if you notice again, I have a negative sign and a positive sign. So those are going to cancel when I add these up. So I'm going to get 2 over. And then in this case, especially since I already did this algebra problem, where I see I'm going to get something squared, I'm going to multiply my denominators together. So I'm going to get 1 minus sine squared x. So what I just did was I rewrote the denominator as, you know, what you get when you distribute all of this stuff. All right, so yeah, when you distribute that to 1 and sine. Okay, so anyway, I get 1 minus sine squared. Now, why is that useful? Well, if you remember, we have this identity, sine squared plus cosine squared equals 1. And so I could always rewrite that as cosine squared equals 1 minus sine squared. And that's going to be super helpful in this problem, because then I can take this entire denominator out and replace it with cosine squared. Okay, so really I have 2 over cosine squared. And then I try as often as possible to eliminate any fractions. So instead of saying 2 cosine, like 2 over the reciprocal of cosine would be 2 times the secant squared of cosine. So that's our final answer, 2 times secant squared cosine. Okay, now we have another problem that practices this very similar skill. Right here, x to the negative 1 minus x over 1 plus y. So all I'm going to remind you of is that this is another way of saying you need to take the inverse, or in this case, because it's a fraction, reciprocal. So 1 over x minus x over 1 plus y. I'd like you to try and get a common denominator right now. So pause your video and try and get a common denominator with this algebra problem. And then when you unpause the video, you will see the answer to that problem. All right, folks, so very similar. I had to take each denominator and multiply the other fraction by that denominator over itself, because that's 1. So like this blue fraction right here, x over x, that's 1. 1 plus y over 1 plus y, that's 1, okay? We can write 1 however we want. And then we multiplied those things together, and then we combined our fractions. Now, if you'll notice 2 things, nothing could actually be like simple, like smushed together. 1 and y and negative x squared are all different terms, so those just all get collected at the top in the numerator. And then I didn't distribute the x because it didn't help me, right? It didn't change anything algebraically, so I just left the denominator in factored form. So as we move into our problem on the right, we're going to have some similar things that we need to do. First off, right now, really not much we can do in terms of simplifying because we have too many different trig ratios. So I'm going to start by rewriting secant as the reciprocal of cosine. And then I'm going to keep, my second fraction as it's written. And now I have 2 completely different looking denominators. So I'm going to need to take the right fraction. So the left fraction has a denominator of cosine. I need to multiply this guy by the cosine of x. And then I'm going to take the fraction on the left, and I'm going to multiply it by 1 plus sine of x over 1 plus sine of x. So again, notice, the denominators basically go to the other fraction, okay? Top and bottom, multiply. And so I get 1 plus the sine of x over cosine times 1 plus sine. Minus, in the top I'm going to have cosine squared because these 2 multiply together. And then I'm going to keep my cosine of x out in front and have 1 plus sine of x. Okay, so at this point I have a bunch of different terms that need to be combined together. So I need to take these 2 different fractions and merge them into 1. So I get 1 plus the sine of x minus cosine squared of x. And then that is all over cosine times 1 plus sine. All right, at this point, there's a couple of different things you could do. What I'm actually looking at is the fact that I have 1 plus sine of x. I could rearrange that. And I could say that this is sine of x plus 1. Why would I want to do that? Well, 1 minus cosine squared. If I look at this Pythagorean identity right here, sine squared is 1 minus cosine squared. So if I kind of rearrange that a little bit using the fact that I know addition is commutative, so if I say sine plus 1, the 1 minus cosine squared, that's really sine squared. So I could rewrite that as sine of x plus sine squared of x, cosine of x, and then 1 plus sine of x. Now you might be wondering, how does this substitution help me? Well, now the numerator has a common factor. Both of those terms have a sign in them. So I could factor out a sine of x, which would leave me with 1 plus the sine of x. And the denominator has a cosine, and then that same exact factor, 1 plus sine of x. That means those factors are gone, because that's really just 1. And this part that's left over, that is just the tangent of x, which is our final answer. All right, so the key thing here is to make sure you understand how to get a common denominator, and then the second part, that you actually put those two fractions together into one, okay? And then you continue to manipulate that after you combine the fractions. Most important step is get a common denominator and combine. If you only do half of that, you are not going to be successful with this particular skill. So get a common denominator and smush those two fractions together. All right, thank you so much for listening. Enjoy the rest of your day. Bye, folks.